Good morning!
I'm your radio teacher,
I am your science buddy.
and I'll give you an exciting lesson that you'll surely enjoy.
Sci Talks Radio. Education must continue.
Learning is a great avenue.
No one will be left behind. With new normal comes new learning.
New method, new way of understanding.
Keep on learning.
Keep on achieving.
There's no way of hindering.
Enriching one's strength.
This is Sci Talks Radio, your number one source of science education. Conveying a half an hour of quality scientific teaching on air.
This is
Sci Talks Radio.
Have a good and safe day, my grade 10 learners. How are you today? Before we will start with our lesson in this episode, let's have a short exercise. Are you ready?
Yes, sir.
Everybody, do what I'm saying. Breathe in, breathe out. Breathe in, breathe out. Breathe in, breathe out. How do you feel? Doing such simple exercise will let you feel better and release some stress that you have. As we go on, stay tuned here at Radyo Eskwela for the Science 10 Quarter 4 3rd Week episode. This is Redency Andres, your radio teacher for this episode. Are you ready to listen?
Yes, sir.
Before we start, be sure you have your pen and paper for you to take note important facts or information about the lesson. And of course, your water to replenish your body, ready to beat the heat.
Okay.
Last episode, we listened between the relationship of volume and temperature. At constant pressure of a gas, it was explained that the volume is directly proportional to temperature at constant pressure. So, what does it mean? Yes, it means that when the temperature increases, its volume also increases. May I check if you really understood our last lesson? Get your pen and paper and compute this sample problem about temperature and volume within 2 minutes. Here is the question. A sample of gas occupies 3 liters at 300 Kelvin. What volume will it occupy at 200 Kelvin? I repeat, a sample of gas occupies 3 liters at 300 Kelvin. What volume will it occupy at 200 Kelvin? Your time starts now. So, what is your answer, my dear? Yes, the answer is 2 liters. Let's check. So, in the problem, the given are temperature 1 is equal to 300 Kelvin. Temperature 2 is equal to 200 Kelvin. And the volume 1 is 3 liter. And the unknown is volume 2. We know that volume 1 over temperature 1 is equal to volume 2 over temperature 2. Therefore, the formula for volume 2 is V sub 2 is equal to T sub 2 V sub 1 over T sub 1. Substituting now the volume of each term, volume 2 is equal to 200 Kelvin and 3 liter over 300 Kelvin. Cancel the same unit and perform the indicated operation. And the answer is, substituting now the volume of each term, volume 2 is equal to 200 Kelvin and 300 liter over 300 Kelvin. Cancel the same unit and perform the indicated operation. And the answer for volume sub 2 is equal to 2. Did you get the same?
Yes, sir.
Very good. You deserve a clap for that. I think you are now ready to explore more. Are you ready?
Oh, yes.
Let's go! So, at the end of the lesson, you are expected to explain the relationships of gas using the kinetic molecular theory. Okay, let's explore this KMT or the kinetic molecular theory. Sit back and relax and find a place for you to listen. KMT or kinetic molecular theory is a law that explains the relationship of volume, pressure, and temperature in a confined container. This theory has been proposed through experimental results. In order to explain the behavior of gases at molecular level, such theory was proposed by James Clerk Maxwell together with Rudolf Clausius and Ludwig Boltzmann. It explains why volume and pressure is inversely proportional to each other, and why volume and temperature is directly proportional. This theory is based on the following postulates. First, gases are made up of atoms or molecules that move in random motion. Gas molecules are always in constant random motion. Throughout their motion, these molecules travel in straight line unless they collide with. As a result of collision, they will bounce off and change direction, but their energy of the system remains the same or constant. What can you observe with the small children when they already learn how to walk? Yes, your observation is correct. A gas is like a child that constantly moves from place to another in an unpredictable fashion. This assumption is correct. Furthermore, the KMT assumes that particles travel in straight lines until they bash into something, at which point they turn around and go somewhere else. Like the case of small children, this assumption is true. The assumption that gas molecules are in constant random motion explains why they have to fix shape or volume. Secondly, the distance from one molecule to another molecule of gases are so wide compared to their individual sizes. Distances from one molecule to another are far greater than the molecule's dimensions. A gas is mostly empty space or with negligible volume and mass. Third, the force of attraction between gas molecules is almost negligible. This postulate means that the molecules of gases neither attractive nor repulsive. Molecules will not attract, but rather they will collide to each other. In real life, especially this time of pandemic, can you give practices to not be infected with the virus? Yes, correct. Gases are assumed to be like people practicing social or physical distancing protocol. Interaction is minimum to avoid or not to be infected with this virus. Yes, the collisions between gas or molecules and the walls of their container are perfectly elastic. This means there is no loss or gain of energy among the particles. Lastly, movement of gas molecules is affected by temperature. The average kinetic energy is directly related to the temperature of gas. This means that the lower the temperature, the lower the average kinetic energy, or vice versa. When a substance is heated, some of the absorbed energy is stored within the particles. When a substance is heated, some of the absorbed energy is stored within the particles, while some of the energy increases the motion of the particles. This is registered as an increase in the temperature of the substance. Kelvin is used instead of degrees Celsius because gases often exist at temperatures below 0 Celsius. As a result, if we said that the kinetic energy of a gas was proportional to the temperature in degrees Celsius, the kinetic energy of any gas cooled below the freezing point of water would be negative. Is it clear, 10th graders?
Yes, sir.
Okay, may I test how clear your sense of hearing is? Get your paper and we will have a short activity. I will give you 10 seconds to answer. Shall we proceed?
Oh, yes.
Right correct if the statement is accurate and wrong if the statement is flawed. Number 1. The particles are in constant, random, and straight line motion. The answer is correct. Gas molecules are always in constant random motion. Did you get it?
Yes,
So
sir.
here is number 2. The attractive forces among particles are negligible. Wow, nice job! It is correct. There is no attraction of gas molecules. You got it! For number 3, the average kinetic energy of the gas particles is equal to the absolute temperature. Very good, it is wrong, since the average kinetic energy of a gas is related to its temperature. Here is the number 4. The collision of the particles with each other and with the walls of the container changes the kinetic energy of the particles. Good job, my dear learners. The answer is correct. The motion of molecules is due to the collision and the walls of the container. Lastly, at higher temperatures, the collision of the gas particles with the walls of the container becomes more often and with more force, thus producing a lesser pressure. So, the answer is wrong because when the temperature increases, the pressure also increases. Congratulations! You did well on this activity. A round of applause. In this episode, you have learned that gases have mass, volume, temperature, and it exerts pressure. The kinetic molecular theory of gas helps us understand the inverse relationship between pressure and volume. Pressure is created when gas particles collide with the walls of the container. And every time a gas particle collides with the wall, it exerts a force on the container wall. As the average force exerted by the gas particles increases, the pressure of gas increases, thus decreasing the volume of the gas. From the kinetic molecular theory, the average kinetic energy of gas particles is directly proportional to the temperature of gas. The particle's average kinetic energy is related to its speed. The temperature of the gas is increased, the particles move at higher speed. This results in frequent collision of the particles with the walls of the container. So the gas particles exert a greater force on the walls. The pressure exerted by molecules are due to collision among gas molecules and with the walls of the container. The frequency of gas collision is affected by temperature because gas molecules moves faster at high temperature. On the other hand, they move slowly at low temperature. The faster the movement of the molecules, the more frequent the collision, causing an increase in pressure. To further check whether you understood our lesson, let's have a short quiz. Write your answer on your activity or answer sheet. Number 1. Which of the following refers to the forces exerted by molecules on the wall of the container because of the collision of molecules? A. Density. B. Diffusion. C. Mass. D. Pressure. I repeat. Which of the following refers to the forces exerted by molecules on the wall of a container because of the collision of molecules? A. Density. B. Diffusion. C. Mass. D. Pressure. Number 2. Which property of gas is explained by the kinetic molecular theory? A. Gas exerts pressure. B. Gases are widely separated. C. Gases are in constant random motion. D. All of the above. I repeat. Which property of gas is explained by the kinetic molecular theory? A. Gas exerts pressure. B. Gases are widely separated. C. Gases are in constant random motion. D. All of the above. Number 3. Which of the following gas principles best explains why it is advisable to keep aerosol away from heat and flame? A. Gases inside the aerosol are always moving very fast. B. Volume of gas varies directly with temperature. C. An increase in temperature causes an increase in pressure. D. Temperature varies inversely with temperature. I repeat. Which of the following gas principles best explains why it is advisable to keep aerosol away from heat and flame? A. Gases inside the aerosol are always moving very fast. Volume of gas varies directly with temperature. C. An increase in temperature causes an increase in pressure. D. Temperature varies inversely with temperature. Number 4. Which is not an observable property of a gas? A. Mixes homogeneously with other gases. B. Varies its shapes and volume to fit the container. C. Highly compressible when enough pressure is applied. D. Expands infinitely and distributes uniformly. I repeat. Which is not an observable property of a gas? A. Mixes homogeneously with other gases. B. Varies its shapes and volume to fit the container. C. Highly compressible when enough pressure is applied. D. Expands infinitely and distributes uniformly. Five. According to kinetic molecular theory, which of the following statement is true of the molecules in the gaseous state? A. They have the same average kinetic energy at different temperatures. B. Gas molecules move randomly in different directions, continuously colliding with one another. C. Gas molecules show large attraction for each other due to the wide spaces separating them. D. Larger molecules have greater velocities than smaller molecules at the same temperature. I repeat. Number 5, according to kinetic molecular theory, which of the following statements is true of the molecules in the gaseous state? A. They have the same average kinetic energy at different temperatures. B. Gas molecules move randomly in different directions, continuously colliding with one another. C. Gas molecules show large attraction for each other due to the wide spaces separating them. D. Larger molecules have greater velocities than smaller molecules at the same temperature. Are you done, my dear learners?
Yes,
Great!
sir.
Let's check your answers. Remember, you must be honest in checking your answer. Here are the answers. For number 1, the answer is letter D. Answer for number 2 is D. For number 3, the answer is letter C. For number 4, the answer is letter D. And number 5, letter B. Good job, 10th graders. Count and write your answer in your paper. Did you get a good score? If yes, keep it up, my dear, and if you are not contented in your score, try to answer your activity found in your SLM or LAS. Don't forget to pass your output to your teacher. If you have a question about the topic, you may contact your science teacher for inquiries through call, text, or FB Messenger. Congratulations, everyone! Remind your parents to be on time in passing your answer sheets following safety protocols. Okay? We are done with the third week of the fourth quarter, my dear grade 10. I hope that you have learned something about our lesson. Keep your passion to learn over the Radyo Eskwela episode of the SDO. On behalf of the scriptwriter, Ginaline B. Suge, this is Rodensi Andres, your radio buddy. Until our next episode, keep safe and God bless.
Patuloy ang edukasyon para sa ating henerasyon.
Sa daan ng pagkatuto ay walang may iwan.
Kaya halina sa Radyo Eskwela!